All right, our next visit into waves, we're going to talk about waves in general and their properties. There'll be a little bit of math, a lot of terms, things you need to know. So we'll talk about properties and then waves themselves. All right, so definition of a wave. A wave is a disturbance that moves from place to place, carrying energy. Okay, disturbance that travels carrying energy. In general, waves travel from place to place, and this is what's important. But the particles move back and forth. Okay, so for example, you have a string attached to a wall here, and as you move the string up and down, the wave moves this way, but the string moves up and down. So this particle on the string stays here while the wave travels that way. First type of wave is a transverse wave. It's a wave where the particles move perpendicular to the energy. So the particles move up and down, the wave travels this way. Particles move up and down, wave travels that way. Okay, so transverse waves. Particle moves up and down, but the wave moves perpendicular to the particles. Longitudinal waves are waves where the particles go parallel with the energy. So, like a slinky going back and forth, you got where they compress and then where they expand. So compressions and expansions. And the coil moves back and forth, but the wave goes in that direction. So they move parallel to each other, while in a transverse wave, things are perpendicular. Water waves are kind of a combination. So let's say we take something and we drop it into water, like a pebble, like here. What happens is the waves go out in all directions. But in a water wave, the particle, and we're going to look here at this, as the wave goes to the right over here, this object moves in a circle. Okay? And water waves, as they travel, objects will move in a circle. What causes you to go are currents, and then also tide is what pulls objects in the oceans. But we see an object, if they would float, would stay in the same spot. It would just go in a complete circle. And that's how water waves work. Some definitions. You got crests. You got troughs. You got amplitude. You got lambda, which is wavelength. Then you got equilibrium position. Equilibrium position is the starting point of each particle. The crest is the highest point. The trough is the lowest point. These distances, or these displacements, will be the same. So if this is 1 meter, this also will be 1 meter. Wavelength is the distance between two consecutive crests or two consecutive troughs. Velocity, speed, obviously. Amplitude is the distance from equilibrium to the highest and lowest points. So to the crest and to the trough. And then equilibrium position, of course, is where you start. Okay, so again, definitions: crest, highest point; troughs, lowest point; wavelength, from one crest to the next or one trough to the next. We use meters to measure this. You can see it in different units, but of course SI is always in meters. Wave speed equation. Speed is equal to wavelength times frequency in the units of speed, meters per second, just like when we talk about the speed of an object on land. But speed of a wave, wavelength times frequency. So here's an example. So sound waves travel with a speed of 343 meters per second in air. And that's, air temperature would change that a little bit, but essentially that's our average. The frequency, the lowest sound you hear is 20 hertz. The highest frequency is 20 kilohertz or 20,000 hertz. So find the wavelengths of sound waves having frequencies of 20 hertz and 20,000 hertz. So velocity is wavelength times frequency. All right, to find wavelength, it's velocity over frequency. So I will take 343 over 20 and 343 over 20,000. 343 over 20 gives me 17.2 meters. And then 343 over 20,000, 0.0172 meters, or 1.72 centimeters. Just the use of this equation. Other words that come up: medium. The medium is any form of matter. So it could be air, it could be water, whatever. It's any form of matter. The speed is determined by the medium through which it travels. So speed of a sound wave, or speed of any wave, is determined by medium. Different mediums will cause waves to have different speed. When we talk about sound, you think about sound in the air versus sound underwater, how it sounds different, and that's because of the speed through the medium. Mechanical waves are waves that travel through matter. So waves that need a medium to travel through are mechanical waves. Sound waves, they need to have air or something to vibrate to transport the waves. But light waves, on the other hand, travel through space. And so in space, light waves travel, but there's no medium in space. It's empty. So therefore, they're not mechanical waves. So light's not a mechanical wave, but sound is. No sound in space. One thing that happens with waves is they reflect. So let's talk about reflection. We have a wave traveling at this speed. It comes to a fixed end, so it's joined to the wall. When that wave hits here, it bounces back. When it bounces back, it inverts. So at a fixed end, waves invert. If we have what's called a free end, as the velocity goes this way, it will move up, and as this free end moves, the velocity is not inverted, or the wave's not inverted. So wave reflection at a fixed end inverts. Wave reflection at a free end moves. And you'll see that with simulations.